So the question is going to ask us for the area of this triangle, and we've quickly stated without actually going about it, saying that this isn't a right angle triangle, and we know this angle's not right angle, this one's not. So we've kind of assumed, and we'll prove it in a second. But we have to use trig in order to kind of find some of the sides in order to find the actual area. So one of the things you started with, which is great, is the area of a triangle is equal to the base times the height divided by 2. Great, we got that out of the way. We just need to figure that stuff out. Now, one of the problems here is to find the height of any triangle, you have to have a right angle, okay? Which means I'm going to need a base, and if I call this the base, well then the side that is to a right angle of the other side would be the height. That looks like an H, okay? And you could flip this triangle right back around and do the opposite and call this the base. So imagine I took this triangle and I kind of like flipped it this way. This could be the height. It doesn't actually matter. You just need two sides that are perpendicular to each other. That's what's really important for this. So we know that all angles, so the sum of, they call them the interior angles, sum of interior angles of a triangle. They technically say you have A plus B plus C equal 180 degrees, okay? So assuming we have that, we can quickly figure out this unknown side here, or this unknown angle, I should say. And you did it really quickly. You notice that those two were 80, so you said this one had to be 100, which is perfect. So we have a 100-degree angle. Very nice. So that proves that it's a non-right angle. Mm-hmm. So our challenge now is to get a right angle. I wish I could just draw straight lines on here. I'm sure there's a way, I just don't know how yet. I'll figure it out. So a right angle would be something like that. Okay, we could do it that way. I mean, we end up having to like find this side, which we're going to have to do anyways, but then we got to find other angles involved. I mean, actually, this is a way we could do it. Oh, no, I'm lying, because it does have to get up to this height. So splitting it there is not going to help. To me, the way I envision this is I just actually want to extend this just a little bit, this triangle, to do this, okay? And what ends up happening is we end up needing, let's do a little highlighter, we end up needing this triangle. And that triangle there is going to be right angle. So we're just going to go about and say, there's a right angle triangle. Great. So think of this as two triangles butted up to each other. Okay, so we have our original triangle. We have 3 angles in a side. That's a lot of information. We can definitely solve for the missing sides. This new triangle, I have an angle, essentially because I put it in. It shares a common side here. So we're going to solve that, because that will give us a side. Mm-hmm. Then we're going to have to figure out a couple other pieces of information, which are going to be a bit more difficult. We're going to need at least an angle. You need 3 parts to solve any triangle. We have an angle. We're going to solve this side. We'll call this side X. We need one more piece of information. We can already actually figure that out right away. I'm going to redraw the original, just in a kind of a scaled version. Okay. Not so nice, that one. But if this is 100, and this is a straight line, do you know what this angle would be? 100? It would be 100. Do you know what?
It adds to be 80?
It adds up to 180, so this side is 80. Exactly. And what actually happens is that is this part right here. Mm-hmm. This part is 80. So we actually have 2 angles. Before we do anything, we already have 2 angles. We got the 90-degree angle, and we got an 80-degree angle. And once we find this side, that gives us 3 pieces of a triangle, and then we can do anything we want from there. Mm-hmm. So we kind of problem solved before we actually went into the question. That's what we're going to attempt. So let's move to a clean page here. I'm going to attempt to redraw it again. I know it gets worse as I do it. But what's important here is this was 30, right? Yeah. Mm-hmm. This one was 50. This was 50 centimeters. Mm-hmm. And what we really need to start is we're going to focus on this side here. So we need to solve this side. Another really quick way to tell if you're going to use sine law or not is, do you have a complete ratio? So do you have an opposite side and an opposite angle? So if we take a look here, oops, that's not, there we go. I got this side, but I don't have the angle. This angle here,
We have
this is on side. Ah, good. And this angle here would be opposite of this side here, which is unknown. So at first glance, it looked like we didn't have it, but then you recalled, oh wait, we do have this angle. It's 100 degrees, so great. Let's not use cosine law. Let's actually use sine law and get through this. So here we go with sine law. Let's set it up. We have sine A over A equals sine B over B equals sine C over C. Wonderful. Well, I didn't actually name anything. It doesn't actually matter for sine law. For cosine law, it does.
Yeah.
What we can do is, so we get into the practice of it, remember, because we're memorizing one version of cosine law where we solve for a side C, let's name the unknown side C. That way we get really used to that, okay? So if this is side C, which angle would be angle C?
50.
50, very good, right? And then the other two, they actually don't matter, so let's kind of just arbitrarily name them. I think I was doing A's in red before, so if that's A, that's side A, which gives me, this is B, side B. Wonderful. So let's fill out our laws here. So sine A is 30. Side A is still unknown. Sine angle B, we said was 100. And side B was 50. And then finally, sine angle C is 50 degrees. And side C is unknown. Okay, well, we have a lot of information. Which one of these ratios do we not really need for what we're doing?
A.
A. We don't need A because we're not solving for it. Great to know. And we have enough information, right? And this is a unique scenario. A lot of ways you tell is, oh, I don't have anything, so I drop it. But in this case, we had more information than we're used to having. So you're right. A is unimportant to what we're trying to do now, so we'll drop that ratio off, and we're left with sine of 100 over 50 is equal to, I'm going to get you to take your calculator out to help me along with this. And we can call that, I'm going to keep it as C. Are you okay with working, we call the variable C instead of X, yeah? So a fast way to set this up is to cross multiply right off the bat. So we take the bottom here and multiply there, and the bottom here multiply here. And this gets rid of fractions for us. So we have C multiplied by sine of 100 is equal to sine of 50 times the value of 50. Okay. Well, the whole goal is to isolate for C. So I'm actually going to move sine 100 over, and then we're going to just do this all in kind of one shot. So to move it over, because this is multiplied, I have to divide this whole side by that. So what we'll end up with is C is equal to sine 50 times 50 over sine 100. I should have actually put the whole thing in brackets. I didn't mean to do just that. Sine 100. And now we're going to solve for that part there. Did you say you did this part already? You solved for this side? What did you end up getting when you got this side? 38?
Yeah.
38.3? Okay, so let's say we got that, and that's correct here. 38.3. So we assume we punch that all in the calculator. Sometimes we make mistakes, sometimes we don't, but that's okay. Let's go with that number there. So now we have that number there. It's really important. I'm going to redraw that triangle one more time. I'm going to actually try to draw it, dot it. Oh, God. Because the goal here is to actually build a new triangle, right? We'll do it in blue. So we have this side we just discovered is 38.3, is that correct? Centimeters. Yeah, that's logical. Okay, I just want to make sure it's logical compared to the other side we had. And we're building this new triangle here. We said this was a right angle. Do you remember what we said this angle was?
80.
Oh, geez. Yeah, that's right. It's 80. Good. And the goal here, do we need to know what this base is?
Yes.
Or do we need to know what this height is?
Both.
You're thinking, because you're thinking of the formula base times height. But remember, the base is actually this part here. This is not part of the base. This is an imaginary triangle we're building here.
Oh, right.
So this
Just
base
ahead.
is actually not important for what we need. This base, which we never solved for, is going to be important later on, so we are going to have to solve for it. It's this height, though. That's the real missing piece here. So we need to solve for this height. So again, I'm going to name it C, because we're just really used to doing that, right? Which then means that this angle is angle C, and then the other two, we'll call this angle A, side A, angle B, which we don't know, and this will be side B, which we don't need to know. And if we take a look here, this is a right angle triangle, so I can use SOHCAHTOA to solve this. But since we're kind of on the sine law and cosine law kick, I'm going to keep using that. And right away by looking at it, and we could test it by putting both in, but I have a ratio. I have this opposite side and this opposite angle. That's an indicator of sine law.
Okay.
I got to use sine law, okay? So let's set it up real quick again. Sine angle A is 90 divided by side A, which we discovered to be 38.3, is equal to sine angle B is unknown, and so is side B. So that's kind of your indicator that we don't need that part of the ratio. And then sine angle C is 80. Squeeze it in there, we'll fix it after. And side C is our unknown, and we purposely set that up. Okay, so that drops off. We're left with sine 90, which is 1, I'm pretty sure. I'm quite sure. I'm pretty sure it's 1.
Yeah.
It is? Okay, yeah. Equals sine 80 over C. We're going to cross multiply again. This becomes C multiplied by sine 90, which I'm going to substitute the value of 1 in a second. Sine 80 times 38.3. So really what you got to solve in your calculator while I'm finishing this up, find out what sine 80 is, whatever that value is, and multiply it by 38.3. Since sine 90 is only 1 times C is just C. And when you multiply the two,
37.7.
37.7? That makes a lot of sense. Because this one's kind of on an angle. This one's straight line, so it'd be a little shorter.
Right.
And 37 is a little shorter than 38. Okay, logically, that's making sense to me. So it's great. So now let's try to piece together some of our information. In fact, actually, we never solved this side here. We have to go and use sine law again. Did you end up solving it before? What did you find that side to be?
25.
25? Great. So all we would have done, I'm not going to show that part, is just reapplied sine law. It was 25 on the dot?
Yeah.
Great. Centimeters. So we got 25 on the dot. Let's build that last page here. So let's start piecing together this info. Oh my god, I'm terrible. I should stop drawing that one first. Okay. So, we said this is 25 centimeters. That's the base, okay? So we're going to call that our base. We know that our height is 37.7. Is that what we said?
Yeah. 37.8. Yeah.
8, 7, yeah. Okay. 8 we'll go with. Centimeters. And then we had a whole bunch of other info like 50 centimeters and 30 degrees and 50 degrees and 100 degrees, and this is 80 degrees, and this is 90 degrees. We had tons and tons of info, but for area of a triangle, we only need the base times the height over 2. Well, that's our height, and that's our base. Only important information for the last part of this, okay? So the area, the area of this triangle is equal to 25. I'll do it in blue, so it kind of matches. 25 times, you might need your calculator for this part, 37.8. And then whatever that is, divided by 2.
47.1. 471.
Oh, 471.25 centimeters. And because it's area, do you know what the notation is for area?
Centimeters cubed.
Square.
Square.
Square, yeah, because square deals with 2 dimensions, so we use the value of 2. 3-dimensional space is volume, that's when we use the value of 3. So there you guys, we got it over 4 pages of work. There's a lot in that question to figure out. That was a tough one.